Hello, my friends of Qatari Labs. This time we are going to do a tutorial about modeling soil erosion with Landlab in Python. Okay, so what is Landlab? In fact, Landlab is a framework that runs on Python that can process many processes on soil erosion, like on surface dynamics, like geomorphology, hydrology, glaciology, and stratigraphy. Okay, this time we are going to run erosion as slope erosion over 4,000 years with Landlab on Python. So for this, we are going to use Jupyter. Okay. Okay, here is okay, and then I'm going to open a folder, and then I'm going to create new notebook. On this new notebook, it will be soil erosion. Okay, great. Cool. And well, first we are going to import NumPy and Landlab, but we are going to import just one raster model grid because actually Landlab can work with Voronoi and rasters. Then we run and PyLab inline in order to have the graphs after the code. Okay, we are going to define a model that is of 80 rows and 120 columns, and each row and column has a space. I mean, each grid has a space of 2 meters. Okay, why do I do that? Is because I'm going to set a hypothetical model. You actually with Landlab you can import your raster file, yeah, but this time we are not going to do it, so we are going to set a hypothetic an hypothetic raster. Okay, actually what we have is, okay, we are going to define in our raster the elevation will be topographic elevation run, and we are going to create a plot about with the nodes that we are dealing with. Okay, so it's 100 is 80 rows and 120 columns. Okay, and the amount of nodes is 9,600. Okay, but this, if you see here, it will be zeros. So what does it mean? That all the elevation on this raster is 0, but actually it's not 0 because otherwise there won't be an erosion. So we are I will put what I will do is I will create a surface here. This is a surface that varies with the x coordinate and the y coordinate, and it has I mean, the surface has a slope, but as well it has a steep slope. So here, and I will show you the aerial view of the surface, and this is the first platform, the second platform, and there is a steep slope here. If you want to see the slope, a cross section of the slope, I will run this, and here you can see this is the steep, this is the slope the first platform, the second platform, and the steep slope. Okay. Okay. Then we are going to put a parameter of soil erosion, and then we are going to assess which is the delta of time for the evaluation. So the delta of time of evaluation, it will be 80 years. Okay. Okay. So we are so what does it mean that each time step it will be every 80 years? Okay. Then we need some boundary conditions, and the boundary conditions is that actually the soil, the erosion can exit just by this, just here. I mean, like water, I mean that soil eroded, one can go out in this direction, near in this direction, near in this direction, just in this direction. Okay, and this is what we have it here. Okay, we run it. You know that you can run it with this or with Shift Enter. So if I'm not doing this, it's Shift Enter. Okay, and then Shift Return, Shift Enter, Shift Return. Okay, and then since you have defined all the boundary nodes as, since you have defined all the boundary node as boundary condition, all the nodes on the boundaries on the ref, light, and top boundaries, you will have less nodes because the nodes that are on the boundaries are boundaries. Okay. Then what we are going to do is that we are going to run the model, the erosion model, and this is the code that runs the erosion model, and it will range 50 time steps. If each time step is 80 years, so it will run for 4,000 years. Okay, so because you want to actually see the erosion. Okay, under this parameter. No? So if this parameter is bigger, so you have a lower time step, so you will see more erosion in less time. Okay, so we run this. Okay, actually it's pretty fast, and then I'm going to see the topography of this is the topography of the last, this is the final topography. So if you see from this one, you will see that there is a change. Okay, but actually I want to see that change, and I can see a cross section here. Okay, look, there is a change from the beginning. Look, this is the beginning and this is the eroded, but I will use the interactive tool of Jupyter in order to see I wanted to see the evolution of the soil slope. So in order to see the evolution of the soil slope, I will use IP widgets, and I will create an interactive plot where I can see how is the surface in every time steps. So here I have surface at the beginning, and then if I go in every time step, so for 45 times 80 years, it will be this. For 20 plus 80, so 1,600 years. 1,600 years, it will be this. 800 years will be this, and this is at the beginning, no? So if you see, you can see the evolution here. Okay, on the description of this article, of this video, you will find the input files, I mean this code, so actually you don't need it to type it. I will strongly recommend that you go to Landlab GitHub.io, and then you go through the user guide, and then as well you go through the tutorial, because there is a lot of methods. This is just about one method that we make it run, but there is a lot of methods there, and then we are as well interested in researching in the other methods. Okay, so my name is Saul Montoya. We are from Hatari Labs. What is Hatari Labs? Hatari Labs is a website related to the knowledge sharing in open source software in water resources. Okay, so we have a lot of tutorials on Modflow, Python, QGIS, and every other open source software. Okay, so we have as well in OpenFOAM, and we have some webinars as well. So please follow us in our Facebook profile, our Twitter profile, and then you can sign up for a newsletter. So just drop your email here, and then you will receive a newsletter each time we post something interesting for you. Okay, so please follow us. My name is Saul Montoya once again, and was nice to contact you this time, and hope to see you in our coming tutorials. Have a great day and see you. Bye-bye.